When you hear AI, your mind probably jumps to chatbots or maybe some app on your phone. But there's a quieter and, honestly, a much more profound revolution happening right now. AI is fundamentally changing how we design and build the actual physical world around us, everything from airplane parts to the machines humming away in a factory. So let's dive in and see how AI is becoming the ghost in the machine, shaping our world from the ground up.
So, let's start with a big question, one that really frames this whole shift. What if a computer could literally dream up a part? I mean, something that's not just a tiny improvement on what we already have, but something totally new, lighter, stronger, and optimized by physics itself. Well, guess what? This isn't science fiction anymore. It's the new reality for engineers.
And it all starts at the very beginning of a product's life, the design phase. This is where AI is making the leap from being just a simple tool to becoming a full-on creative partner, and it's completely rewriting the rules of invention.
The difference here is, well, it's like night and day. The old way of designing things is slow. It relies entirely on an engineer's personal experience to make these tiny, step-by-step improvements. But generative design, it just flips the whole script. It's automated, it's fast, and it explores this massive landscape of possibilities to find answers that are literally baked in the laws of physics. So what exactly is generative design? Okay, think of it like a partnership. The engineer is the boss. They set the rules of the game. Hey, AI, I need this part to hold this much weight. It has to be made of aluminum, and you can't go over this price. And then the AI goes and plays the game, generating hundreds, sometimes thousands of different designs that follow those rules. And they often come out in these weird, almost alien organic-looking shapes that a human would just never think of. And listen, this isn't some niche experimental tech locked away in a lab somewhere. The biggest players in the industry are all in on this. Autodesk was way ahead of the curve, building this into their Fusion 360 software way back in the late 2010s. They used the power of the cloud to just churn out a ton of design options. And it definitely doesn't stop there. You've got PTC's Creo software, which also uses the cloud, but with a real focus on making sure the parts can actually be built. See, the AI doesn't just create these beautiful abstract sculptures, it creates designs that are ready to hit the factory floor, challenging our old ideas about what's even possible to make. But it gets even smarter. Siemens NX software takes this whole concept to another level. Its AI is like a seasoned veteran who's been at the company for 30 years. It actually learns from all the past designs a company's ever made. Then it uses that deep internal knowledge to suggest solutions that aren't just innovative, but also fit right in with the company's own proven way of doing things.
Okay, so we've used AI to dream up these wild, futuristic-looking parts. Awesome. But the big question is, will they actually work, or will they snap in half the second you put any stress on them? That brings us to the next critical stage, testing and simulation.
The old way was just a huge bottleneck. I mean, you'd design something, then you'd have to send it over to a simulation expert, wait for hours, sometimes days, get the results, make one tiny change, and then start that whole waiting game all over again. The new way? It just completely shatters that process. You make a change, you see the result instantly. So how is that even possible? Well, tools like Ansys Discovery are harnessing the raw horsepower of GPUs. Yep, the same kind of chips that are in high-end gaming computers, and pairing them with AI. It turns simulation from this slow, painful process into a live, interactive experience. It's seriously like playing a video game, but the game is controlled by the actual laws of physics. You can pull and stretch your design and watch the stress points update in real time.
And the impact is absolutely staggering. Get this. In a project between SimScale and NVIDIA, they created an AI model that allowed engineers to test over 50 different pump designs in just a few seconds, a job that, with the old methods, would have taken weeks of computer time. That is the kind of leap forward we're talking about. All right, so we've designed our part, we've tested it in the virtual world, now it's time to actually make it. Let's move from the digital realm of design into the noisy, physical world of a factory, where AI is making things smarter, faster, and way more reliable. First up, quality control. On a production line that's moving super fast, a human inspector can get tired. They can miss things. But a vision AI, something like Landing Lens, it never blinks. It can spot microscopic cracks, scratches, tiny paint defects with superhuman focus, making sure a bad part never ever makes it out the door. Then you've got amazing stuff like metal 3D printing. Incredibly powerful, but one tiny flaw can ruin a part that costs a fortune and has been printing for days. So AI tools like Peregrine basically act as a guardian angel.
It uses a camera to watch every single layer as it gets printed. If it sees a tiny problem, a little hotspot, a small warp, it can flag it immediately, saving that part from ending up in the scrap heap.
A factory only makes money when its machines are actually running, right? Well, AI is now being used to listen to the very heartbeat of the machinery. By analyzing sensor data, vibrations, temperature, the AI learns what a healthy machine sounds and feels like, and because of that, it can predict a failure before it happens, which prevents these massive, expensive shutdowns.
And AI is even changing the business side of making things. In the past, if you wanted to know how much it would cost to make a part, you were in for days of back and forth phone calls and emails with suppliers. Now, platforms like Xometry use AI to analyze a 3D model you just upload, and within seconds, it spits out a price and a delivery date. It directly connects your design to the cost. So we've seen AI as a designer, a tester, and a factory supervisor, but its impact actually goes even deeper, right into the day-to-day life of an engineer. AI isn't just in these big fancy tools. It's becoming a co-pilot for pretty much everything an engineer does.
I mean, think about all the grunt work that comes with engineering. AI assistants are now tackling stuff like digging up research papers, drafting boring reports, and even helping debug code. But the real game changer might be in capturing knowledge. Imagine a tool like Colab that scans your new design and automatically pops up a warning like, hey, just so you know, a really similar bracket failed a vibration test on that project 3 years ago. That's not just saving time, it's preventing the same mistakes from happening over and over. It's a huge force multiplier.
And this brings us to what might be the single most important takeaway from all of this. There's a lot of fear out there about AI taking jobs. But in engineering, the goal isn't replacement, it's augmentation. By taking over all the tedious work, AI frees up engineers to stop being just problem solvers and become problem framers. People who can ask bigger, more creative questions and focus on the really strategic challenges that matter. So what we're really seeing is the birth of the augmented engineer, someone whose own intelligence and creativity are being amplified by these incredible new tools. They can explore more ideas, check them faster, and build them more reliably than ever before. And that leaves us with one pretty exciting final thought. With all these new superpowers, what incredible things are they going to build next?